living by the beach part and couldn't read any further out of jealousy. So I'll let his speech do the talking for him. So can we all welcome David Tulloh?
Thank you. Thank you for attending. This talk is about implementing GUIs on Internet of Things devices rapidly, and a way of doing it which brings a whole bunch of unexpected benefits through the structure that you can use. So because this is an Internet of Things talk, I brought a thing as a crutch, a prop, along. So this is my thing that I'm going to be talking about today. We have our GUI, very, very basic. We can normally, of course, on an Internet of Things device, this would be a small touch screen, but I thought requiring everyone to bring binoculars would thin the audience a bit too much. So this is my oversized screen. This is my ancient finger emulation device. And when you touch on the screen, the ball changes color. So the ball is my output. We have our glowing orb, and the glowing orb can switch colors. It's all controlled by a little banana Pi. It's kind of like a Raspberry Pi. It's not yellow, but the Raspberry Pis aren't red, so I think that's okay. And I've got some arbitrary input, GPIO input, some big buttons. If I hit the red button, it goes red. If I hit the green switch, it goes green. And you'll see that the state is reflected through the system. So if I hit the red switch here, the ball goes red. The GUI signifies that I've got red. And then we can go back and we switch. The mouse doesn't work well on the glass. So the GUI that I'm using here is actually web-based. You should probably get this out there pretty early on. I hate GUIs. I hate writing them with a passion. I've basically never subjected anyone who's been willing to pay me to my own GUI work. Using tkinter or something in Python, it's okay for other people, but you know, horrid. Just don't want to go anywhere near it. So this is a web page. It's a fairly basic web page. On the left, you can see a representation. On the right, that's the full HTML that's driving this web page. The front half is a bit of JavaScript, jQuery. It's small. You're not meant to read it. This is a Python talk. So I'm just calling it a jQuery object, which renders my thing for me because I'm cheating. And the second half builds a WebSocket connection. I should probably say, so this is all running the web browser, etc. is all running on a basic Linux system. The web browser is a very basic embedded Chromium browser. It just gives us a single page. You can serve this off the local file system if you want, but it seems fairly obvious that you can extend this quite easily and have a separate client which interacts with the system. So this, if I break the third wall and use a mouse, is that over here. This is fantastic for development work. You can run this off a basic web server running on the device, or you can run it off the file system of the PC in question when you're doing development work or when you're doing a presentation and you're worried that things might break. So this is the Internet of Things, done. Tick. It's internet. Whoop, I need to get back to my slides. So the server side consists of 3 classes. Again, don't try and read this. I'll zoom in a bit in a little while. So the left-hand column, you've got a light ball class, which controls the light ball. The center column is the WebSocket class, which provides all of our connection. And the far side is main, which fires up Tornado, which is the library I'm using to drive all of this. So if we zoom in, this is the light bulb. This is all of the code for the light bulb. There's sorry, I have trimmed the list of colors. It's just an array. So you can see we're holding a state for the system here. Very simple get, set, and then the actual communication to the hardware ball is over infrared. So I'm just calling IR send to update the color that I want to see. This is the first half of the WebSocket handler code. This code actually is, I think, the most important code in the system. It's the magic that makes this all work. A new instance of this WebSocket handler is created for each connection. And there's a global array hiding up the top there that you can see, which just contains a list of all of the clients that we're talking to. So when a connection's opened, we add to that array. When a connection's closed, we pull out from that array. And when we send a message, when we receive a message, we take the incoming message, little JSON string, process it, and then the updated, which changes the state of the system, and then the updated state is sent to every single client. So there's no, I think it's quite important to avoid sort of state machine, next state stuff when you've got clients like this, because you get out of sync. So every client gets refreshed full state every time it changes. That's all. That's 5 lines of code, and it allows this structure. This is the second half. Comparatively, it's fairly dull. We do the processing and the updating here. Essentially, I'm just bringing in a JSON string, pulling out the color, and then the update rebuilds the JSON string, sends it out again. And then the main code. This is a basic Tornado application. It listens on a port for WebSockets, and it just handles it. Right. So we've created a WebSocket which allows communication in and out. If you add documentation to that communication layer, which of course you were going to do anyway, I'm sure, you've got an API. Almost any programming language supports WebSockets. You publish that document, and you've got a system for anyone to write any client to hook into your system, get your state, update your state, control your thing, figure out what's going on, carry on that conversation. For effectively no work. Authorization can be hooked in if you require it. It's essentially a web system, so any of those standard web authentication models, I've implemented OAuth 2 over a system like this, can be done. Just need to keep in mind your requirements for your device and its connectivity. Back-end clients. I think this is where it gets really interesting. So I've showed that you can hook multiple front-end clients in. That's fairly obvious once you start with a web system. WebSockets allow extension on the back end too. Heavy processing or sections of code which you need to write in a lesser non-Python language for some reason, libraries or because you need true real-time, something like that. All of that can be written as another program, and then you link in via WebSocket. The Python control code, the Python backend is in control of the system. It maintains the state. It coordinates all of the other clients and commands the system. But you can use additional clients like this one. This is a C WebSocket client. This is actually running on this board to control these switches. It allows me to not worry about nice things when trying to interact with the GPOs. I run a C program and I just pull the schmeck out of it. And then I let Linux handle handle the multi-threading type stuff for me, because it's a different program. It'll just work. I'm not going to go through this. It's somewhat off topic. But the highlighted code is all the code that I had to actually write for this system. It would halve if I only had one switch, but the rest of it is basically a simple example of how to connect to a C WebSocket that I just downloaded off the internet and spliced in what I needed. So it's easy to do. Dist-end backend clients are possible as well. I don't have a demo for this one, unfortunately. But in a complex embedded system, what you tend to end up with is multiple chips. So you'll have your central processor, which will be a reasonable sized ARM. You might have an FPGA or a CPLD or little micros, sort of Arduino style systems around. And then you communicate generally by serial port, because it's nice and it's easy, and something like Ethernet is just huge overkill on the board. Serial ports, as I'm sure everyone knows, are very basic. You open a pipe, you just throw text data back and forth, bidirectional port. A WebSocket, you open a pipe, you just throw data, bidirectional, back and forth. If you needed to, if you wanted to, it's very, very simple to create a emulated WebSocket for a serial port. Because if you dress anything up in a duck suit, you can make it look like a duck. And that's really powerful, and it keeps control in a very simple structure of code. But there's more. These days, it doesn't seem like you're properly IoT if you don't have an app. It's sad, but it seems to be true. And you probably figured out by now, I'm a cranky old curmudgeon. I'm not into writing apps. It took me a couple of days to even get Android Studio installed nicely on my system. There's this interesting new thing that Google's pushing called progressive web apps. They bear remarkable similarities to the Firefox OS concept of what an app would be. Essentially, it's a web page, and it's locally cached so that you can use the system. Right, insert demo here. So, whoa, wrong one. So this is an emulated Android system. This is running connected to our thing. So to build a progressive web app, you need to fulfill 3 criteria. It has to come across as SSL. This is by far the hardest criteria to fulfill. Doing this on a embedded system is not easy, and I'm not going to give you the solution to that because I don't have it. We need to supply a manifest file. It's just a basic JSON file, and we need to have a JavaScript service worker, which is essentially a file that you download off the internet and you stick next to your app. So the JavaScript service worker is what does the caching for us. So when you open this on your phone, you go to the URL and you open the URL on the phone. The second time that you go to the URL, the user will be prompted if they want to install this as an app. They can, at any point in time, click, and say to add to home screen, and it'll become as an app. There is support, this is Android, supported by Chrome. There is support for the Apple and Microsoft operating systems, a bit less, but it does work. If you go to the home screen, you can see that I've installed this already. If I click it, it comes up, and it looks like an app. And this is, I can't stress how easy this is to do. You know, someone like me can do it this morning while watching other talks. Woohoo! Okay, so summing it up, we've got a WebSocket server that sits in the middle of its own little spider web. You can have attached to it all sorts of clients. You can have things like the attached screen. You can have remote web clients. You can have your public API, your Android app, all on the front end. On the back end, you can have long-running processes, real-time processes, license-restricted processes. The application which is controlling my buttons, for example, is GPL due to the library that I'm using for that. And then anything that was like an attached microcontroller can be swung in through there. So I feel important to get any questions. The source code for this, the slides and the code used is all available on GitHub. So you can go off and you can create your own glowing orb of awesomeness.